Hello, fourth grade geologist Adamson here. Can you smell what the rock is cooking? Well, not really cooking, but we're going to be cooking up some science lessons, but ching about rocks. So I have my good friend the Rock right there. He has come back to help me out. So thank you, Rock. Well, we're not going to talk about that rock that does the wrestling and is in movies. We're going to talk about rocks that the earth makes. The earth is right now making rocks as I am standing here. It's working on rocks, and it is trying very hard to make rocks. Well, what are rocks? Rocks are clumps of hard earth materials and minerals. So it's stuff that's found under the ground, and it's a mixture of the earth's crust and the mantle kind of coming together. Okay. Rocks tell us a story. Do tell. So, rocks tell us a story about what happened to the earth over years. When you see a cliff that is striped with layers of rock, each layer tells us a story. The bottom layer is the oldest layer, and it was formed a long, long time ago, probably before humans were here. Then each layer on top of that tells us some different information. Wow, those look a little weird on me, okay? So, we are going to learn about rocks, and we are going to know that rocks tell us clues and tell us information about the history of the earth. If you love rocks and you love digging in dirt and you love getting kind of icky, this is the lesson for you because rocks are all over the place and you have to dig deep down sometimes to find them. Now, what is so cool about rocks is that rocks can tell us how the land used to be. So let's say a scientist discovers this fish bone, okay, this fish fossil in an area that has no water. Well, looking at the rocks, they could maybe decide and figure out that, well, there's not an ocean here or a lake here now. Whoops. But there was once an ocean or a lake here. So, rocks can tell us basically the history of life and the history of organisms here on Earth. Rocks are so cool. So, we are going to dig into the three types of rocks. Today, we are going to focus on one type of rock, and then tomorrow another, and then another. So, all rocks can be put into three categories. Okay. There's lots of different types of rocks, but three major categories. And a person who studies rocks is called a geologist. They study the land, they study the rocks. Okay. So they decided that there's three major categories that all rocks fit into. And under those categories, there's all different types. Okay. So let's focus on category one. Category one is one of these options up above. So the three categories. One of the categories was made near a volcano. One of the categories is based on rocks being made under the sea. And one of the categories is based on heat and pressure. So today, drum roll please, we're going to focus on the types of rocks that are made from volcanoes because we've already learned about volcanoes. So, the volcano rock is called the igneous rock. So, igneous rocks come from volcanoes. There are two major types of igneous rocks, and we will explore those in just a moment now. Igneous rocks are made inside of a volcano and outside of a volcano. So, inside of a volcano, it's a little bit different process because it's magma inside and is a lot hotter. On the outside of a volcano, it takes not as long, and that is the lava that turns into a rock. So, first, what I wanted to show you is I have my candle melter here. This is a little warmer, and I have put a wax cube in it, and you can see that it is hardened right now. So this is kind of like the inside of the earth. It's got smushy type of rock that's inside of it, but it can get heated up. So I'm going to go put this on my warmer for just a minute, and then I'll tell you how this relates to rocks, okay? So it's warming up right now, okay? My hands are a little gunky. So next, igneous rocks are called volcano rocks, well, because they come from a volcano, okay? So we need to understand how it is formed. So they are formed in two different ways. First, they're formed by lava and magma. Well, remember, we already know the difference between lava and magma. Lava is on the land, Magma is in the magma chamber on the inside. So we need to think of igneous rocks as kind of like ice, okay? So ice can melt and harden when you put it in the freezer. You can harden water, okay? So I think of igneous rocks of kind of like ice, okay? So the magma inside the volcano is getting all kind of liquidy, okay? And it melts. So in my class, we like to act things out. I say it, read it, do it, remember it, okay? So we're going to practice this. So we say igneous and we pretend we erupt. Ready? We're a volcano erupting. Okay, we erupt, we melt, and then we harden. Okay, let's do igneous again. Ready? Erupt. Melt and harden. Okay, that's basically how igneous rocks are formed. Of course, it goes into more detail, but basically the rock melts, the lava melts, the magma melts, and then it hardens and it becomes a rock. Okay, one more time. Erupt, melt, harden. Excellent. All right. So let's dig in. So igneous rocks are wherever the lava or magma cools, okay? That's why they're volcano rocks. Now, the first category is the intrusive igneous rocks, okay? These are found on the inside. Do you see that? The beginning of intrusive has an I-N for inside. So the magma is cooling and hardening under the ground. Once it cools and it gets hard, it becomes a rock, okay? The extrusive igneous rock is formed on the outside. It kind of starts with the letters that the word exit starts with. So the way my brain remembers that is extrusive is it exiting the volcano. Okay, so it's the lava and it hardens on the outside. So intrusive is inside, extrusive is bye-bye outside. All right, now the fun begins. So intrusive rocks form on the inside and they take forever to form, kind of like my wax now. Okay, it's still gone. It takes forever for it to cool because it's so hot inside that volcano. So it's so hot. It's so hot. Okay, but eventually inside there it will harden and all these crystals will start forming and it'll look something like this. Okay, and geologists will find this and they will see it and they'll be like, whoa, look at what this volcano made, okay? And it takes forever for this magma to cool. But once you do discover one of these type of rocks, you're like, wow, this is amazing. So one of the intrusive rocks that you see in front of you is one that I have right here. Do you guys know what this is called? Do you know what these are called here? Let's see. Do you know what these type of rocks are? Huh? 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 Well, let me tell you. So look at these rocks a little bit closer before we make the decision on what these are. So they have crystals, they have coarse grains that are kind of mixed together. All right, now watch. So this first one is called granite. Have you ever heard of granite? Granite is maybe in your kitchen. If you have granite countertops, you have intrusive igneous rock inside your house. What? Isn't that really cool? So go ask your adult at home and say, hey, are these cabinets? I'm not cabinets. Are these counters? Are they granite? Because if they are, you have a volcano rock in your house. Let me show you what it looks like in a kitchen. No, we're not going to my kitchen. I just have it on the next slide. And no, this isn't my kitchen. This is just something I found online. All right, so this countertop right here was made from this right here. They take it from the volcano area, they put it into machines, they add stuff to it, and bada bing, bada boom, you get granite countertops. How cool is that? That this little bitty rock is now being used in homes all over the world. And people are cooking on them and making meals on them. How cool is that? Okay. And they're also beautiful. It's hard to scratch this type of countertop and it's low maintenance, which means, well, guess what? It's not very hard to take care of. So a lot of people decide to put granite in their house. That's one type of intrusive igneous rock. All right, the next type that we have is diorite. Diorite is not as common, but it comes from the volcano on the inside. And then we also have another one called gabbro. Gabbro is just another category of rock that is found inside the volcano. It's the intrusive igneous rock. Now, one that people use every single day, and it looks like this. What do you think this is called? Look at it, look at it, look at it. So, this is pumice. Pumice is an extrusive kind of rock. So this is a little bit different, okay? The extrusive kind of rocks are very, very light. They're exiting out, so they can't be heavy coming out. They have to be very light. If you're an in-person person, you will get to feel this. It's different, it's bumpy, it's light, and this floats on water. And you know what? Most rocks don't. This one doesn't because it's kind of hollow and light. Okay. So when you come to in person learning, you will actually get to feel how light this is and you will see it float on water. Magical. Now, this little thing is also used for a lot of other things that people use every single day. Okay. So this rock is used to help people have clean feet and not nasty looking feet. So a lot of times this is put into a little pad that people use to scrub calluses off of their feet, and they scrub and they scrub. If you've ever got like your toes done at a nail salon, they often use this on your feet and they kind of clean off all the dead skin that's on there. And again, this is an extrusive, which means it's outside of the volcano that it's made, okay? And the reason it's a little lighter, I want you to think of it this way. It has to be light to leave the volcano, okay? So it's very coarse and it really it can be used to clean things, okay? And it doesn't feel like a traditional rock. So this is another one that's an extrusive kind of rock. We're not going to go into detail with this one because I don't have a rock to show you an example for it. But again, it has those holes and it kind of looks bumpy-ish, but it has more holes and it's hollow and it's see-through. Here is another one, and I do have this one. So this one's an extrusive, and I honestly love black jewelry. Like I have a black diamond jewelry at home and I have an obsidian necklace at home. So this is obsidian and it kind of looks like a shiny piece of black glass. Okay, it's often called nature's glass because it looks like glass. This is made on the outside of a volcano as well. It's also very light. It does not float, but it doesn't have crystals. Where the intrusive ones have crystals, these are all very smooth and have no crystals whatsoever. So if you find a rock outside that has crystals in it, most likely it's an igneous rock, but it's an intrusive igneous rock. Now, I love obsidian. I think it is just so beautiful to look at. And I love the black color of it. And I love to think that this was once in a volcano. I just find that so fascinating. Okay. I want to show you some more examples of what obsidian is used for. So the Native Americans would use obsidian to make their tools and their arrowheads. This one can be heated up and put into lots of different shapes too. So this one is just, I just love obsidian. It's so pretty. It's one of my favorites. So obsidian is fairly easy to identify because it's black. It's one of the only rocks out there that is black in color, okay? So if you find a black rock that is shiny, you probably have an obsidian rock, and more importantly, you have an igneous rock, okay? So the category is igneous, the type is obsidian, and it's made on the inside or the outside. Let's think. Was this one the inside or the outside? It was made on the outside. So it's an extrusive rock. So who knew rocks had so many categories and so many ways that they could be identified? So they also are oftentimes in a C shape, the obsidian. Okay, so if you ever find this black shiny piece, it's an obsidian. Now, obsidian was a very useful tool back in the Stone Age because it could be made into knives, arrowheads, spears, scrapers, and so many weapons. So the Native Americans and the people who were here long ago found out that this was actually a really good resource to use for everyday life because, of course, they didn't have weapons yet, so they had to create them to help protect themselves. So they used the natural resources to help them out. And obsidian helped out in many ways. Nowadays, people use obsidian for jewelry, and they're used for all sorts of things. They're used for tools, and it's also used for some tools that are used in surgery. Different types of surgeries they've used obsidian with. And I just think I just like when like you wear an obsidian earring or a necklace, it kind of sparkles. Now sometimes people think that obsidian is actually a black diamond. So if you see black jewelry at a store, it's most likely not a diamond. It's just been shaped into a diamond shape. Really, it's just obsidian, okay? And so what it would look like not in a jewelry is just like this, and then they put it in a machine and they turn it into jewelry. And that's what a diamond is too. A diamond is just really a rock. So that makes me ask the question, why are wedding rings and everything so expensive if it is literally just a rock? Ladies, think about that. Think about that. Jewelry is basically you're just wearing a rock, more or less. Diamonds, rubies, emeralds, all rocks and minerals. Interesting to think that they're so expensive. Moving along. This you heard about when I was talking about volcanoes. This is basalt. This is an extrusive type of igneous rock that hardens and forms new land. A lot of time, land is formed with basalt. So basalt is found under the ocean a lot of the time. Wait a minute. Does that mean there's volcanoes under the ocean? Hmm. Well, I guess it is possible that it is under the ocean. Let's look at this a little bit more. So, basalt is the most common rock on Earth. A lot of it's under the water. Most of the ocean floor is basalt. Well, you might be thinking, wait a minute. If basalt is magma that's cooled, that means that magma must have been underwater. Because remember, magma's inside a volcano. So, how would it get on the ocean floor if magma's inside the volcano? So, did it erupt out? What happened? How did magma get under the water if magma's inside of a volcano? Hmm. Well, it's because there are many volcanoes under the water. Well, the volcanoes don't just erupt through the crust like it would on land. It doesn't come out of the crater and erupt. It works a little bit different under the ocean, and especially around the Ring of Fire, which is that Pacific Ocean area. Well, it doesn't come out of a crater. It kind of creates a crack, and it doesn't. Well, let me just show you. So here's how this works, okay? When we talked about plate movements, we talked about divergent. Divergent plates pull apart. So when the Earth's tectonic plates move away from each other, these divergent plates, okay, magma actually comes up out of the magma chamber. So it's not coming out of a full volcano and actually hitting land. It's just kind of cracking up a little bit, okay? So then it comes up on the ocean floor and then it cools very, very quickly and forms new seafloor crust. So it's not actually coming out like lava, it's just kind of oozing through a crack, okay? It's kind of like if you scrape your knee or you hurt your arm and the blood is kind of like magma. When it heals, it kind of comes out of your skin a little bit. So let's say this is the ocean floor. You get a cut on the ocean floor, the blood comes out, it hardens into a scab. That's basically what this basalt is doing under the ocean floor. So it is technically still magma because it's not too far away from the magma chamber. It's not coming out of a crater like an actual volcano that is on land. So that's why it is still considered a magma. And that is again so fascinating. And the best way to describe it is like a scratch. So, a scratch on your arm, the blood comes out and it hardens. That's what's happening with this basalt, okay, on the ocean floor. How cool is that? Basalt is all over the world, okay? It is used in roads, it's used for concrete, it's used on the sidewalks outside, the asphalt outside, and so many purposes. If you're driving along on the road, you are on basalt. Now, of course, basalt has been kind of mixed with other things, but it is actually from a volcano, and we use it for so many different things. And here is my basalt. Again, it looks like this, and then they mix it together with other things. So here are some review. So there is one more idea that all rocks that are igneous have in common. Okay, they could be they could be the extrusive, they could be our intrusive rocks. But there's one other thing. One other thing. Can you think? Can you think? Can you think? Do you know? Do you know one other thing that makes them so different? It is. They don't have layers. So sometimes you'll find rocks that have layers. And by layers, it looks like this. They kind of come in layers. So it's kind of like a cake. You have the cake, the icing, the cake, the icing. Okay. These igneous rocks do not have layers. So if you're walking outside and you find some rocks, well, guess what? If it doesn't have a layer, then it might be an igneous rock. So that's cool to see how they don't have layers. Now, let's review igneous rocks. All right. So there's two types: intrusive from the inside of a volcano, extrusive from the outside of a volcano. Then, if you find rocks out there, so go exploring today. Go look after school today if you're in person. If you're at home, well, go outside and go look for some rocks. So, if you find a rock that has no layers, has crystals, looks like glass, think it is igneous. All right. And again, igneous comes out, melts, and then hardens into a rock. Okay. So, examples again that we've talked about for your intrusive rocks are on the inside. There's the examples I've talked about. Here are some of your extrusive rocks we talked about, the kind that come out. Okay. And then what you're going to do is you are going to now fill out this chart. Tell me, how are igneous rocks made? I want you to tell me characteristics of an igneous rock, okay? So what do they look like? Some of the ways they look are they look like glass, they have holes in them, they are shiny. And then the last category you're going to do is tell me some examples of the rocks that I've discussed with you today. So after you fill out this chart, you do need to go do a real quick form where you match the type of rock that I talked about on here and see if you can identify them. You will need these slides and my video to answer the questions. So go look. I would love for you to go look for some rocks. And again, if you find any that have no layers, are shiny, you're probably got an igneous rock there. So go explore and happy hunting, my geology